Now we'll move on to the webinar on how does the Ingestion Framework work, which is the actual marketing name of the real topic, that is that we are not married to any orchestrator, right? So if you need to leave the meeting with just one idea in your mind, is that Airflow is not really needed to run all of the ingestion process, right? And in order to understand why, in order to really just dive a bit deeper on how does the Ingestion Framework work and how can you use it in your own orchestrator, in your own processes, let's first have a quick look on the actual orchestration architecture that we have in OpenMetadata. The usual flow is I'm a user of OpenMetadata. I go to the OpenMetadata UI and I create an ingestion. And then this action of going and creating an ingestion, what it does is it deploys a process on an orchestrator. In this case, out of the box, we are bringing Airflow, and this orchestrator is just going to run some specific processes. It's going to trigger this Ingestion Framework module that it's going to be the one in charge of going to the source system, being your databases, your dashboards, your ETL services, absolutely anything that would happen here. The Ingestion Framework will go to that source, will extract the metadata, run all of the updates, run all of these operations against the server through the APIs, so that the user can go and can explore and can discover the metadata from the UI itself. I think that we all have clear this architecture, but if we zoom in a bit deeper, we're going to understand more how we have actually designed this Ingestion Framework. Because again, we don't really need to run that on Airflow. Our only requirement between the OpenMetadata server and the orchestrator is that we want to be able to deploy these processes, to deploy these ingestions in a dynamic way, right? We just want to have somewhere that we can run an API call, and then the orchestrator receives this API call and spawns the actual Ingestion Framework, this actual Python component that it's going to be the one ingesting the metadata. But as you can see, the orchestrator is just a box. That's just the place where, for convenience, we want to make sure that, okay, I want to run the Snowflake ingestion every Monday. So we need a place where we can configure this actual scheduled process. But the business logic, the actual interesting piece of software, when we are talking in the universe of OpenMetadata, that's the Ingestion Framework, which is nothing more than a Python package.
Quick interruption. Gaten, there are some questions in the chat that you can answer. And then also, if anybody has questions, just post it in the chat.
Thank you. Nadia, don't be shy with the questions. If you have them now, go into the chat. If you sleep on it and have questions tomorrow, you can still reach us out on Slack. So please don't keep anything to yourselves. Now, going back to this image, if we then just try to translate this specific piece of architecture, this specific piece of logic on how this looks with Airflow and how this looks with our out-of-the-box deployment process, we would see that we have the OpenMetadata server that does a call on a custom layer of APIs that we have developed specifically so that the OpenMetadata server can have this dynamic deployment of ingestions. Airflow does not bring out of the box this way of creating DAGs out of an API call. So we just had to build this layer on top. What Airflow actually does very good is that it brings us the possibility of actually building and developing on top of that. So if you're actually curious on how this development of these APIs look like, everything is just part of the repo. I'm just putting here the link if you want to try to understand a bit more all of this logic. But as I was saying, the important piece, the actual magic happens only within the Ingestion Framework. Then if you would like to say, hey, I don't have Airflow, I would just like to run on Dagster, I would just like to run on any other orchestrator. If there's this way, if there's this connectivity layer so that the OpenMetadata server can directly communicate with the orchestrator to run and deploy and trigger these ingestion framework actions, then you can completely swap out Airflow and just put your favorite orchestrator here and manage it directly from the UI. But yet again, important piece here is the ingestion framework. And let's just stop here for a while, because in the end, this is not magic, this is science. So let's show a bit the science.
Couple of questions, Pere. Can they use step functions? They can also use cron tab.
You can use absolutely anything where you have a Python environment that you can trigger a function. So either you can directly, let's say, do the development and the adaptations on the OpenMetadata server so that this communication between the server and the orchestrator system happens, basically replicate the same logic that we have done in this interface that makes the OpenMetadata server talk to Airflow. That would be one way. But if you just don't care about managing the ingestions with the UI and you'd rather just reuse any other systems, if you have Python access, you would be able to just go ahead and run the ingestions from absolutely anywhere. And then the goal of the demo here, I will try to explain a bit the ins and outs on how you can create just a Python script for you to run the ingestion process. And we will also show you a full, complete alternate method on how to run this ingestion, which is using GitHub Actions. And the actual first piece to start understanding how the ingestion works is by understanding how we are defining these YAMLs. Because for us, when we are talking about the ingestion, we are just talking about this process of, I need to connect to a source, I need to extract some metadata, do the necessary translations so that I can get the table regardless if it comes from MySQL, if it comes from Snowflake, if it comes from Redshift. I take that, I translate it to the OpenMetadata standard, and then I send it to the OpenMetadata server. And this logic on where do I connect to and where do I leave the metadata after this process has done, we do define all of that in just a YAML file or a YAML structure. And in this case, I'm just going to show you the example on how a YAML like this would look like if we're talking about Snowflake. You can also find all of these definitions directly on the docs. So we have this specific YAML description for any of the connectors that we support. So you can go ahead in the docs, just copy paste and adapt the actual credentials to whatever it is that you need to put to point into your services. Now, in this case, we see that we have a rather simple workflow definition. We have the source where we're saying, hey, I'm just going to connect to a Snowflake, and I have a sink. This is where I'm going to be leaving the metadata, which is just the metadata REST layer. The open metadata APIs are the ones that are going to receive all of these calls. Then in my source piece of definition, I'm just giving the service a name. So if the service does not exist after I run the ingestion, this same process based on this YAML is going to be creating that service. And I just need to add the connection information to get to that Snowflake. So in this case, I will need to inform the username, the password, the warehouse, and the account. And as we are talking about the ingestions, if you remember on the UI, maybe we can also show that. So if I just go to the UI, just to draw the parallels here, and I try to create Snowflake service, this is going to ask me about this username, about this password, the account, the role. All of these pieces of information here are exactly the same ones that you would need to put on your YAML, right? Because in the end, everything is centralized at JSON schemas. We have this metadata standard not only for the tables, but for the connections as well. So the same information that we use to fill out and create these forms is also represented into the YAMLs. And the same would happen if I go to a whatever existing Snowflake ingestion we have, and if I edit the metadata ingestion. Here you see that I can add some database filter patterns, schema filter patterns, table filter patterns, and yet other many toggles. So that's the same piece of information that we can add here on when we are configuring the source that we're extracting the metadata from. And finally, I'm just going to say that, hey, the configuration of this workflow, I'm going to point to our sandbox and my authentication provider, how I'm going to knock on the door of the server and actually be let in to send all of this metadata. It's going to be the native OpenMetadata configuration just by passing the JWT token. And just by having this, I will be able to run an ingestion, get the metadata from Snowflake, and send it to the sandbox. And in order to do that, we are just going to write right now a few Python lines. So the first one is going to be our function. Because in the end, to run the ingestion, we just need one single function that is based on this workflow class. This class is where we have actually defined all of this business logic on how do I go to the source and how do I extract the metadata and how do I send it to OpenMetadata. All of this, you don't really need to care about how it happens because we just have this one single class that knows how to execute all of this logic based on this YAML structure here. Then we will need to put this configuration. Here is where we will add our YAML information, and we can define a single function that it's going to load the YAML configuration, it's going to create the workflow, and I'm just going to execute it. Then I want it to just break down and catch fire if there are some any exceptions. I also want it to print the status of the workflow at the end, and whenever everything's finished, just to stop. And finally, we just put this last piece here to make sure that we can execute this properly. And now I'm just going to copy paste this configuration here in a nice Python style, because as you can see, the YAML needs to have some sensitive information, right? They need to pass users and passwords, and we don't really want to get into any trouble. So as we are using Python to fill in this information, in my case, I have these credentials stored as environment variables, and I can directly ask Python, hey, I don't want to put this directly here, just pick it up from the environment so that all of this code can be pushed into your repo and we don't have any troubles in terms of security risks. And now that I have all of this here, I will just double check what is my metadata version. So in the end, we will need to install this OpenMetadata ingestion package directly from PyPy. And as you can see, I'm in the version 1.02. This is important because my sandbox is also in the version 1.02. Some of you come into the support channel and say, hey, my ingestion is failing because looks like the client and the server are not really matching. This is important for them to match because we want to make sure that they are following the same languages, that they are going to be able to talk to each other. So always, always, always make sure that your client version and your server version are aligned if you want to run these ingestions from your end. And now that I have this here, let me just trigger Python in the other way around, demo ingestion. And as you can see, the metadata ingestion started. And I don't want to keep you waiting here, so I just have another tab where this process finished. And basically, those are the exact same results that you're going to see when you trigger and run this ingestion process directly from the UI or from anywhere else. Because again, it doesn't matter in which box this runs. The only thing that matters is that we are using our Ingestion Framework workflow class that is the one that knows how to execute and how to run all of this internal logic. And just now, switching to the new tab, everything finished again. And if I go into the sandbox, let me just go back into these services, and I have this Snowflake from local service. So you can see all of the connection, everything from my YAML definition gets into OpenMetadata, as well as all the databases and schemas and tables and everything that just happened directly from my laptop, which is quite cool, because what this means is that in order to run ingestions from OpenMetadata, I just need somewhere to run a Python script that looks like this, right? So now let's show an example on how we can do exactly the same as a GitHub action. Let me paste the link here as well, because if you want to redo and follow this demo later on, please feel free to do that. We posted all of these demos and all of these examples in the OpenMetadata demo project, so that you can go and that you can also play with it. And here you will see the same explanation that I just did now. First step, we need to prepare the YAML, check that part we already have. Second step, we need to prepare the Python script, check. We created it, we just ran it. Let me also zoom in a tiny bit. We created it, we ran it in our local instance. Everything is working fine. And then the next step is just going to be creating the GitHub action. And the steps for the GitHub action are also going to be super, super simple. So we just need to give the GitHub action a name. We can then schedule it to run whenever we want. And if we also want to be able to execute it manually, we can add this workflow dispatch. We can even scope a bit more the permissions, because in the end, we just want to read the contents of the repo. We don't need it to have any other higher level permissions in our GitHub repo. And we would just need one single job, because we know that I just need to run one single Python script. I'm going to run it on Ubuntu. And first step, I need to check out the code, right? Because I have here in the same repo the exact same Python script that we now build. I just have created it and pushed it before in our OpenMetadata demo repo. So whenever the GitHub action runs, it needs to be able to check out all of this content so that this script is going to be available. Then we check the Python version for the GitHub agent, and we install the dependencies. This is exactly the same that I did on my laptop. So we create this virtual environment and we install the OpenMetadata ingestion package with the plugins for Snowflake. And again, super important, pointing to the same client version as my server version. And finally, I can just run the ingestion. I activate the environment, I run this Python script, and as I have this sensitive information as environment variables that I want my script to be able to load in order to run the ingestion safely, I just need to pass these environment variables from the environment in this specific action. So we can also take a look here, because in secrets and variables, going into the action section, you can see how I created already on my repo all of these environment variables that help me point into Airflow and help me authenticate against the OpenMetadata instance. And once we have that, let me also show you the final GitHub action here, because it's not just living there in the repo. This is something that we have deployed here as well. So once we have this GitHub action present, we can go into actions. We can find it here. And I can go and I can just execute it. And this will do the exact same thing that I did on my laptop. It's going to pick up the script, it's going to install the dependencies, and it's going to run this few dozen lines of script where mainly we are just adding the definition on how to connect to Snowflake. And this, as you can see, it's just going to do the exact same results. It's going to tell me, hey, I see that there is this Snowflake that it's being configured, and those are the records that I just ingested. So TLDR, Ingestion Framework, you can run it from absolutely anywhere. If you have Python GitHub environment and you want to run the ingestions from there, you can now just go and copy paste it from here. If you know Dagster, if you know Prefect, if you know Dagster, if you know any of these orchestration tools, feel free to just replicate the same Python script in that environment and the same exact process is going to happen here.
Okay, one quick question from Nacho is, he thinks this is manually. Can we explain this also scheduled workflow from GitHub?
Yeah, exactly. So this one here, in my case, because I don't want it to run all the time, I just created so that you can only run it when you click on here. But if we go, where do I have that? In the example here in the README, whenever you create a GitHub action, you can schedule it with a cron expression. So this GitHub action, you'll be able to just say, hey, run every Monday, run every 2 days, run the minute 5 of every hour, depending on your use case. You can just schedule it to whatever makes the most sense in your use case here. Any other questions about this? Awesome. So that's most of the magic that I had to show you here. And let me paste the link to the repo. Feel free to play around that. And what is interesting here is that whenever you have created this script, you can just create any other ingestion. Here you can just change a few lines and have this working not only for the metadata ingestion, but you can have it working for the lineage, for the usage, for the profiler, even for the data insights, for the Elasticsearch reindexing. All of these processes that we currently have running on OpenMetadata, where we have this screen of, let me just example here, that you have this screen on, hey, I want to add this metadata ingestion, I want to do this. Absolutely everything can be run. Yeah, thank you, Teddy. Data quality as well. Because in the end, what this process does is it takes the information from the OpenMetadata server and it translates, however this information is sent from the API, that gets translated into here, into a script just as this one. So all of this dynamism is just to make sure that we can create these scripts on demand, but the actual interesting piece of information happens in only these very small lines of code. And then the last piece here to show, because one cool thing about the GitHub Actions is that you can also send alerts to Slack. So if you just say, hey, this looks good, I would want to schedule all these ingestions as a GitHub action, you can then just go on, add these other new lines. You have the example here to make it work, create the Slack webhook token for your workspace. And if at any point in time there are any issues running the ingestion process, you will get a message into whatever channel you have configured. So as you can see, you can manage absolutely the end-to-end of the life cycle of the ingestion process directly from GitHub and get all of this alerting on your Slack as well.
Hey, Peter, there's a question from Ricardo.
Can you show in the UI how it looks like for block storage like Delta, GCS, Azure? Yeah, that's going to be exactly the same. So for example, if we come here and we say, hey, I want to create, where do I have the data lake here? Want to create the data lake. As you can see, it's going to ask me, hey, do you want to go to Azure? Do you want to go to GCS? Do you want to go to S3? So the process is just going to be the same. You would need to fill out all of these credentials, and we have the translation on the docs. So for example, I can pick this one here, and you can see how you can create the same exact YAML file. In this case, this example is pointing to AWS, but we can then also replicate it, and we should also update it here to point to any of the other cloud sources. Any other question, folks? In that sense, it will read the files per kettle or delta, right? Yeah, it's exactly the same. The exact same logic that would happen when you create the data lake service from the UI, where we pick up Avros, we pick up JSONs. I think that we even pick up proto files and parquets and all these kinds of things. You'll be able to do the same if you just choose to instead schedule it externally by just running this Python script. The internal logic is going to be the same. Awesome. Thank you for asking. Great. So I think that we are just in time. Any last minute questions?
I think Alexander asking metadata description approving process. So can we show that such as description quickly?
Yeah, let's.
I know it's deviating from our use case, but
we can show absolutely anything, folks. We breathe and sleep open metadata, so you can ask anything that you need here. So I will just go here to my favorite table in the sandbox. And as you can see, we have this random description that I actually changed a few hours ago. So we can come and we can say, hey, this might not be really looking good. We can click here on the request update description. Let me zoom in a tiny bit. And the assignees by default is going to be the owner of the table. In this case, this is the payments team. And I can come and say, actually, no, this is even better. And just by clicking on submit, I have created this task into the platform, and whoever belongs to this payments team is going to receive here in this bell, they are going to receive a notification. So as you can see, Teddy, a few days ago, he requested me a similar request description task. So I would be able to come here and see my tasks as well as in my profile. And then we can have a full discussion here. Does this even make sense? We can align in what would be the best description. And in this case, I'm an admin, so I can just go on and accept the description. Otherwise, whoever is the admin or the owner will be able to do that. And they can either accept the suggestion as it is, but they can also close it if this does not make sense, or they can just edit it a bit better, put small smiley face, accept it, and this new description just became part of this table. So if some of your users, you have basically disabled the edit of the descriptions, they are still capable of chipping in, either by suggesting something or either by just coming, checking what were the conversations and creating something new to discuss with the rest of the team. Awesome, Alex. Yeah, I also think that it's pretty cool. I grow pretty bored of the #warehouse channel. So actually being able to centralize all of these discussions and changes here, I think that it's very, very comfortable. Great. So if there are any other questions, feel free to reach out in Slack. Again, as we said at the beginning, please go in GitHub, start the project, join our Slack if you have done that already. And thank you very much for joining here. Thank you for your attention. It was great seeing you yet another month, and really stay tuned for the 1.1 release because it's going to be really awesome. Have a great rest of the day. Thank you.
Thanks, everyone. Bye.